As we discussed when we talked about kinetic molecular theory, we define temperature as the average kinetic energy or speed of the particles of a substance. The faster the particles, the hotter the substance is. And we use a few different temperature scales to measure temperature. So most commonly in the US, we use Fahrenheit. And the symbol would be degrees F. In the scientific world, we use Celsius. So Celsius is the most common unit that we're going to encounter. The symbol for this is degrees C. And there's actually a third unit that's also used, and you're going to use it a lot when we talk about gases, and this is Kelvin. And Kelvin, the symbol is K, capital K. In science, the only two temperature scales that we really ever are going to use are going to be Celsius and Kelvin. We don't worry about Fahrenheit because we're pretty much the only country that uses Fahrenheit in day-to-day life. Everyone else uses Celsius, and if you go into a science-based field of study or a job that uses science, you will always be using degrees Celsius. But even with these different temperature scales, it's important to know how they're related to each other. In the Fahrenheit scale, what we tend to use, water freezes at 32 degrees Fahrenheit, and in Celsius, the same temperature is 0 degrees Celsius. And in Kelvin, it's 273 Kelvin. For room temperature, average room temperature is about 77 degrees Fahrenheit, which is the same thing as 25 degrees Celsius or 298 Kelvin. Body temperature is 98.6 degrees Fahrenheit, which is 37 degrees Celsius or 310 Kelvin. And water boils at 212 degrees Fahrenheit, 100 degrees Celsius or 373 Kelvin. This chart should make it pretty easy to see why we use Celsius most of the time, because most temperatures that we use on a day-to-day basis go from 0 to 100. There's a much easier range to work with than 32 to 212. Whenever you have a temperature in Celsius, just think of these common temperatures that you're familiar with, and then figure out where that temperature fits. So if you have something that's 40 degrees Celsius, you know that's going to be pretty hot because that's above body temperature. And it's kind of interesting to see, well, how are these scales originally defined? So Fahrenheit was actually based off the freezing point of salt water and of body temperature. 100 was about body temperature, 0 was about the freezing point of salt water. Celsius was defined off something a little bit easier, the boiling points and freezing points of pure water. That's why it goes from 0 to 100. These were defined as the freezing and boiling points of water. And then Kelvin is based off of absolute zero. So let's talk a little bit more about the Kelvin scale. In order to understand the Kelvin scale, we need to know a little bit more about the movement of particles. So if you look at what temperature is, the average kinetic energy or speed of the particles, scientists figured out that, well, there must be a slowest possible speed or a temperature at which the molecules stop moving. Because the colder things get, the slower the particles move. So they defined absolute zero. And absolute zero is the temperature at which molecular motion stops. Remember, as the temperature decreases, particles move more slowly. And in Celsius, this point is reached at negative 273 degrees Celsius. So this is at negative 270 degrees Celsius is when the particles stop moving. And this temperature is defined as absolute zero. But instead of always saying, well, the lowest possible temperature is negative 270 degrees Celsius, the Kelvin scale was defined. So the Kelvin scale is based on absolute zero, and therefore it is impossible to have a negative Kelvin temperature. And that's really all the Kelvin scale is. Absolute zero is 0 Kelvin. And then everything else must have a temperature higher than absolute zero when all the particles stop moving. And that is why freezing point of water seems so high, 273 Kelvin. That's 270 degrees above absolute zero. So you can't get colder than absolute zero. It's actually impossible to reach absolute zero, even though scientists have gotten really, really close, within tenths of a degree of absolute zero. Once we know these different temperature scales, it's often useful to be able to convert from one temperature scale to another. Many times, an equation or calculation will require you to use one temperature unit, but all you have is a thermometer or a measurement that's in a different temperature unit. Fortunately, these calculations are very straightforward. So the first one we'll look at is the relationship between Kelvin and Celsius. Kelvin equals C, Celsius, plus 273. And that's it. If you know your Celsius temperature, add 273 to it to get your Kelvin temperature. You can reverse that if you want to solve for C, and C equals K minus 273. Other useful conversions, although they're not going to be used as much, is Fahrenheit equals 9/5 times C plus 32. And you can reverse that calculation with C equals F minus 32 times 5/9, and that will give you Celsius. So those are the only conversions that you really need for temperature.